This is TWIS, This Week in Science, episode number 542, recorded on Wednesday, November 25th, 2015. It's TWISgiving! I can't undo the overlay. Hey everyone, I am Dr. Kiki, and this is This Week in Science. Tonight we are going to fill your head with a big beam, sperm sizes, and mental microbes. But first...
Disclaimer, disclaimer, disclaimer. It's Thanksgiving time, so it's once again time for giving thanks. So here it goes. Thanks to the scientists, curious minds. Thanks to the method, control groups, and double blinds. Thanks to NASA for telescopes and Mars missions. Thanks again, NASA, for Earth climate observations. Thanks to the chemists, geologists, biologists. Thanks to the physicists, geologists, archaeologists. Thanks to the geneticists, neurologists, climatologists, and thanks to the cosmologists, robotologists, and zoologists, too. Thanks to the mathematicians, statisticians, funk musicians. Thanks to the engineers, research pioneers, and for all of you with ears. Thanks to the minions for listening. Thanks to the Patreons for giving. And special thanks to the awakening awareness in the world for the many bounties that await us each week here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kirsten and Blair.
And good science to you, Justin, Blair, and everyone out there. Welcome to our TWISgiving episode. Lots of thanks, as Justin fully disclaimed in
that was such
the
a good disclaimer.
That was wonderful. Thank you.
Loved it.
Thank you, Justin. And thanks, Blair, and both you guys for being fantastic co-hosts on this show. Let's get on with it. Let's have good science. Thank you, science. Today, what did I bring? I brought stories about a rocket launch and a landing, flatworm heads, and drinks from robots. You know, it's a normal week here. What do you have for us, Justin?
I have breathing in the algae, freeze-dried vaccines, and some little people news.
And Blair?
Oh, you guys are going to be so excited. I brought sperm, blood, and tap dancing.
Wow.
All things that go well with jazz hands.
Okay, without any more jazz hands making an appearance here, why don't we get into the news? So, first story up for me tonight has to do with mosquitoes. Right now it's a little bit too cold for mosquitoes, but there's some really interesting mosquito news. Researchers last year said, hey, you know, I bet we could engineer mosquitoes to be resistant to malaria. I bet we could do that, and I bet we could find some kind of tool to allow us to put a gene for resistance into mosquitoes. How exactly would we have that gene then be passed on generation to generation and always be passed on with a 100% probability and make sure that all mosquitoes ended up with this gene for resistance to malaria? How could we do that? Well, this week, researchers at UC Irvine did that. And you know the tool they used? CRISPR. It's the CRISPR-Cas9 system that we've heard so much about for gene editing. And this story is just fascinating. They've published, I believe, in the Proceedings of the National Academy of Sciences, and they tested their system in the Anopheles stevensii mosquito, which is a mosquito that's on the Indian subcontinent and is a malaria vector. So here in the United States, it would not become an issue if it escaped from the lab, or if the genetically modified mosquitoes escaped from the lab. Not really an issue because we don't have them here, so they wouldn't be able to breed with other mosquitoes of their kind and thus pass anything on. So mosquitoes from another continent. This is the first step. They used this Anopheles mosquito to genetically modify them so that they put a gene that allows the mosquito to create an antibody that is targeted at malaria, at the parasite malaria that infects them. And with that antibody, it pretty much confers, if the mosquitoes are producing the antibodies, it confers resistance to malaria. So they tested these mosquitoes and they showed that, okay, it's kind of like the Punnett squared Darwinian, just heritability. So things getting passed down at about a 25% rate, 20 to 25 to 50% rate without any further modification. They used the CRISPR-Cas9 system to cut not just the one chromosome that they had inserted this new gene into, but the other chromosome. So in mating, there's this concept of assortative mating. So there's a step in which if you have two chromosomes, only one of the chromosomes passes on a gene. The other chromosome is silent. And so if you have the gene on one of the two, there's a 50-50 chance that that gene is even going to get passed along. Unless, of course, that gene is on both chromosomes. Then you have a 100% chance of the gene getting passed down. They use the CRISPR-Cas9 system to incorporate the gene into both chromosomes in these mosquitoes, and they've been able to show that they have basically a 99% inheritance rate. And they are waiting for society to decide whether or not these mosquitoes are something that should or could be released into the wild. But they say they have a system that could potentially eradicate malaria.
And so here's the dilemma. First of all, I totally get it. I see why we would want to do this, right? This is eradicating a horrible disease that we've spent billions of dollars combating and failing. On the other hand, while this breeding process is going on, it's going to be like, well, I want to hit the mosquito. I want to kill this mosquito that's drinking my blood, but it's probably one of those that we need its genes to continue. So I'll just let it eat and just put up with being itchy for the next 15, 20 years until this is fully acclimated.
Right. So the question becomes, okay, do we want to release them into the wild? When we do release them into the wild, how long is it going to take before they become really, before they take over the wild populations? Before 100% of these genes are just, we have resistant mosquitoes. And then there's the question, though, of like, what if we know that in some species there's horizontal gene transfer, and that genes do get transmitted from species to species, or from subspecies to subspecies, because sometimes there's hybridization, or we don't really know the downward effects. What's going to happen we don't know what's going to happen downstream. So there's a lot of conversation.
Are we going to end up with a super malaria because the malaria is going to, adapt to this resistance that's there? That's not so great.
Exactly.
I don't want any super hyper malaria.
Right. We don't want to lead to hypermalaria because it pushes evolution of the malaria parasite faster.
Yeah, but then think of it this way: if you're trying to create hypermalaria, this would be the long way roundabout, hardest possible chance of having that outcome that you want. No, that's a least possible case type of scenario. I don't.
Well, I'm not saying someo's trying to create it. I'm saying that it's not out into the world.
If your worst case scenario is this hypermalaria, and you wanted to make a hypermalaria, creating the malaria resistance to the way the malaria is even spread in its current form now seems like the worst way to go about it. Is what I'm saying. I'm saying that if that was even a possible outcome, it's somebody who's trying to do it wouldn't even bother with this attempt. Is what I'm saying. So yeah, I think it's fine. Release them. Release the mosquitoes. Let them go do their work.
And we do have, malaria is one of the most devastating diseases on Earth at this moment. So it is something that we really do need to figure out how to get rid of, how to eradicate it, and if this can help, that'd be great. If though we can't really figure out how to do that, we could always just try and keep working on our spaceships for getting off the planet, right? We're working on that.
Outrun the mosquitoes.
Yeah, outrun the mosquitoes. Just make sure they're not on the rocket ship before we leave the planet, and we're all good. From mosquitoes to spaceships, we have big news this week. Jeff Bezos' company, Blue Origin. You might know Jeff Bezos from his tech companies, but he also has a space company. It's a rocket company called Blue Origin. It's up in the northwest Seattle area. And they had a rocket launch, a major rocket launch this last week. Their rocket vehicle, the New Shepard space vehicle, ascended to 100.5 kilometers suborbital space and successfully returned to the ground near its launch site. And when I say successfully returned to the ground, I don't mean it fell to the ground. I mean it went through re-entry, and then it fired rocket boosters, and it pretty much put itself in an upright position and settled itself back onto the ground near its launch site.
Totally.
In a vertical position, in a controlled manner.
Wow.
This is something that SpaceX has been trying to do. They've tried on multiple occasions and have not been able to make it work. So now we have quite a space race between Elon Musk and Jeff Bezos for their, space rocket prowess. I don't know. And there have been, Ars Technica has been keeping track of the tweets that have been ongoing between Jeff Bezos and Elon Musk. And in some of these tweets, Elon Musk at first congratulated Blue Origin on a job well done, and then went on to say, well, this, not just making it up into the air is not the same as putting a rocket in outer space, which SpaceX is doing with their giant rockets. So there's a little bit of one-upmanship happening here, which is kind of fun to see. Then moving on from the space news, we also have high-power beams. More big science. CERN's Large Hadron Collider reported this morning that they have started firing their collider at they're using lead ions, which are very dense, to investigate quark gluon plasma, and they have been smashing them and reaching peta-electron volt energy levels in their collisions. And they say the lead ions are so dense and there's so much material coming out of them that the pathways of the subatomic particles that are coming out of the collisions are super complex and much more complex than they have seen in previous collisions. So this is going to be, it's very exciting to consider what they might be seeing. What they're trying to do here with the lead ions and this, looking at the quark gluon plasma, is to see if at this peta-electron volt level, that this super high energy level of acceleration and collision, if they can see anything different than other experiments have seen, looking at how these particles break down, which they're trying to really get at what was going on a fraction of a second after the Big Bang. what things might have looked like then. And so they're looking for any strange signatures, anything different from previous experiments. And so we will see. They've shot their beams.
Sweet.
Mhm. It's very exciting news. And they didn't. These are not just test beams. They're actually collecting data. So hopefully we will see some neat results sometime soon. Yes, and identity for peta electron volts. Yeah, this is this. So you get mega electron volts, tera electron volts, and giga electron volts, and this is peta electron volts. So this is a massive amount of energy, the scale of which is difficult to comprehend. Yes, it's a lot of energy. But really, you think about it, it's like small areas of energy. It's not like a huge beam that's as big as a truck. These are ions that we can't even see with our naked eye that we're talking about. So very small amount of matter being accelerated at a massively high speed. Cool.
Nice.
This is This Week in Science. Justin, you got any stories?
Yeah, this is a fresh update from a science story that we covered several years ago, one that made the mainstream press, even. This is Homo floresiensis, 3.5-foot tall spear-wielding hominid fossil found in Indonesia. Believed to have existed as recently as 18,000, although I've even heard as recently perhaps as like 12,000 years ago. So more concurrent with modern man than Neanderthal. And this has been one of the science's greatest examples of great minds not thinking alike. Was this a new species? Was this a group of diseased individuals? Or is this just an example of island dwarfism? Papers were published in favor of each of these ideas. Now, new evidence has pushed the debate further in two of those directions. This is a team of researchers affiliated with National Museum of Nature and Science in Japan, University of Wollongong in Australia, and National Research and Development Center of Archaeology in Indonesia. They have performed the first comprehensive analysis of the teeth from the skeletal remains of several of the creatures found in the Indonesian island of Flores. So they have attempted to do DNA from the teeth previously, but all those studies failed to come up with the DNA that they needed. They think the drills that they used were burning the little bits of DNA in the layer that they needed to extract it from. So there's been a failure to get DNA, unfortunately, even though we have teeth. Hopefully that won't last for too much longer. But they are reporting that the examination has revealed that the creatures were indeed members of a separate species from modern humans. Separate species.
Cool. Yeah.
Based on the dentists. Let's see. Their paper has been uploaded into the Public Library of Science Online. The team describes their analysis and what they found that led them to their conclusions. And all the researchers looked at 40 teeth. Analysis consisted mainly in comparing and contrasting them with the teeth from 490 modern humans from across the globe and with teeth from extinct human cousins. Their efforts revealed that the teeth were similar in size to those of modern humans, who were short in stature, but other features were quite dissimilar. Some of the traits were similar to those found in other early hominins, while others even were similar to those seen in more advanced hominins. Because of the dissimilarities with modern humans, researchers reject the notion that the teeth belong to modern humans and instead suggest they more likely belong to a species that had derived from Homo erectus, became a separate species, and then experienced the island dwarfism due to living on the island of Flores with limited resources, and the island effect then took over. So they're saying Homo floresiensis is not a scaled-down version of earlier hominins, nor are they modern humans who have been shrunk down, but a separate species that then experienced dwarfism.
I wonder, I mean, we were saying that maybe they were just modern humans that had experienced dwarfism at first, so I guess the same pressures apply. Mm-hmm. The idea that they were on an island, that there was some aspect of their their diet, their energy requirements that led to the dwarfism. But it's so interesting that the closer we look at these remains, we start seeing more and more differences.
Right, and even back then, there's I think the largest camp has been in favor of the separate species for some time, but it always sort of depended on what researchers were looking at. If they were just looking at the brain cavity, you got everything from dwarfism to disease, microphagia, to the the brain would be too small to have used these tools. There was even a suggestion that this is a Down syndrome effect. So all of those by themselves, looking at the skull, were being debated. Then other people were like, look at this wrist. This wrist is too ape-like to be simply a... So the debate was raging in different aspects, depending on what people were looking at back then. Although I feel like it came out in favor of species largely. That would seem to be more people were saying that than anything else, credibly. But this adds another big push in that direction to separate species, as well as and there was I even recall us talking about this could have been just dwarfism to Homo erectus, like
right,
and that was part of the popular thinking too, even though this would have been a slightly different version of the Homo erectus that we're familiar with, but that wouldn't be too far-fetched. But that's what they're saying now: separate species derived from Homo erectus and dwarfed by the island.
I think that's it. It's the way that all the evidence is coming together, because we still don't really have enough genetic evidence to actually put a family tree together and go, this derived from this and that derived from this. We have to look at these traits, and so and the easiest, the parsimonious explanation, right, is we all split from Homo erectus at some point.
Right, and it's easy to forget what we know about other evolutionary trees when we're thinking about humans and what led to humans, because it's just so easy to try to kind of think about that we're special, right? But in every other situation, when you see a certain body plan that works, there's this huge explosion, this huge radiation of a bunch of different types of those things, and then the ones that do the best are the ones that stay around, but everybody else kind of falls back. And so it's the same with the lineage that led to humans too. These bipedal, erect, hominoid things, that was a body plan that worked in a space where nobody else was doing that yet. So it makes sense that nature would have just tried a bunch of those and see who did the best.
and in the most speculative possible voice I can muster, is it a coincidence that the Guinness Book of World Records smallest man is from Indonesia? Could be. Could be. There may have been some overlap.
Huh.
Could be. And we won't have any way of telling. We need to get the DNA. I'm really upset actually that we don't have the DNA to be talking about at this point. They said there was some speculation within this article that there is a test that may be forthcoming in the future that can utilize the DNA that's locked away in some portion of the tooth that the current methods aren't able to extract. So it's not like we won't ever get.
Right.
Or it just seems like if we have 40 teeth, maybe we should try that test with a slower speed drill. Let's see if we can extract still. It's just weird that we haven't gotten anything and we have 40 teeth.
Yeah. Let's get on it. Come on, scientists. Let's go. Let's go.
Stay tuned to find out more.
Oh, wait. Speaking of finding out more, this is This Week in Science, and if you just tuned in, do you know what time it is?
I do believe it's that time once again for Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals?
Whoa. Well, except
Blair's Animal Corner with Blair. Hey, Blair, what you got?
Oh, jazz hands.
Hilarious. So, let's get right into this. Did you guys know that sperm from a mouse is actually larger than sperm from an elephant.
Nope, did not know that. Now I do.
Right? It's pretty weird. So
That's
sperm
weird.
doesn't vary in size too much from species to species, particularly if you look at mammals. But, for example, looking at fruit flies actually have the longest sperm ever described. Whales have sperm that are less than 1/10 of a millimeter long, and that makes them almost 1,000 times shorter than those fruit flies.
Wow.
What?
And as I just said a minute ago, mouse sperm is longer than elephant sperm as well.
So is there some kind of inverse relationship between animal size and sperm size?
Yeah, so a lot of different researchers have been trying to figure this out for a while, because first they were saying, well, the largest sperm is the best because it can compete with other sperm. And there's more sperm competition in animals that obviously do not historically have monogamy.
And when a mouse sperm is competing against an elephant sperm, no.
Yeah, that doesn't happen so much.
No.
But then there's this other theory that animals, it's about how much volume you can create, because the more individual little sperms that you can contribute, they have a better chance of beating it past everyone else to the egg. So which is more important here? And they actually found not only an inverse relationship, this study from University of Zurich and Stockholm, they found an inverse relationship between sperm size and body size. They also found an inverse relationship between sperm size and volume that you can create. Which makes sense, of course, is that if you think about the area where sperm is stored, it is a finite space. So if that space is being taken up by larger individuals, then less individuals can go in that space. That makes perfect sense. But why the difference? Well, so this recent research looking at 100 mammalian species found that essentially they found that inverse relationship, that the smaller the animal, the larger the sperm. But why? Well, it is due to, in the words of the article, the more voluminous female reproductive tract in larger species. So essentially, if you can contribute more volume and the female's reproductive tract is large, then they have less chance of getting diluted in that space and getting to the egg, getting down this very long reproductive tract. In smaller species, when the reproductive tract is very short, then it all comes down to brute strength of the sperm, and that's where the size comes along, is they can fight their way to the egg when it's more about brawn than it is about speed.
Wow. This is interesting. So you've got the size and how much room there is and how much danger there is to the sperm for kind of getting lost.
Mm-hmm.
And then because you're a bigger animal, you can also just create more.
Because none of them will ask for directions. Yes, Justin. Exactly. Yeah. So if you think about, don't think too hard about it, but if you think about a reproductive tract of a whale versus the reproductive tract of a mouse, and the sperm being not that different in size, that's quite a journey in the whale versus the mouse. So you can see how, in the end, it would be more fierce competition, sperm to sperm competition, tail on tail, I don't know. More sperm competition in the female reproductive tract getting to the egg as opposed to just trying to sprint to the finish. So sperm competition, not as simple as we previously thought.
They are still just trying to sprint to the finish line, but
yes,
it's within the relative environment.
Exactly. Yeah.
Yeah.
Yeah, so it turns out bigger the animal, smaller the sperm, for good reason.
Wow.
Now, my other story tonight, I want to tell you guys what I'm thankful for. I'm thankful for TWIS. I'm thankful for you guys, of course. I am also thankful that I have ample food. I am thankful that I do not need to ask other people for food, in that I do not have enough. I am also thankful that I don't eat blood, and I am thankful that I don't eat regurgitated blood. If I were a vampire bat, all of those things would apply.
Yeah.
Yeah. So a pair of researchers, one with the Smithsonian Tropical Research Institute and the other one with the University of Maryland, wanted to look at the vampire bat social structure as it comes to blood regurgitation. So vampire bats go out, they hunt in a solitary way. So they hunt completely by themselves. Sometimes they get a lot of blood, sometimes they get very little or no blood. And then they come back and they actually live in a social circle in a cave. So all in all, they're social creatures, but they hunt on their own. And what researchers previously knew was that sometimes if a bat comes back unsuccessful from a hunt, they will sometimes receive regurgitated blood from another bat.
Yeah, the bats share.
They share. And this is very important because bats have really high metabolisms, and they can starve to death in as little as 2 days.
Yep.
Oh my goodness.
Yeah, so a couple bad hunts, and you're out of there if nobody's willing to share. So these researchers wanted to find out what the social structure there was, who they're sharing with, and why. And the obvious response to that would be, oh, well, they must be related, so there is a payoff for them, even if they don't receive it back after they share, because they're helping out their genes.
There's that. I think I also remember a previous study in which they found that bats remember who they share with, and if they are not, if at some point they're in trouble and a bat they have shared with does not share with them, then they remember that.
Yes,
and so
exactly.
it kind of changes the way that they share and who they share with.
Yeah, so it's quite complicated. So these researchers wanted to look at the exact rubrics for who they would share with and who they would not share with. And they did see a direct relationship with if someone had shared with them before. And this is hilarious. The researchers only tested on females because prior research showed that sharing between bats accounts for 80% of those sharing situations are among females. So females are really willing to share. Males sounds like not so much. So
I wonder why that would be, though. Is it because there's more male competition generally?
It could be. It could also be that they also raise their young together, so it could have to do with that dynamic as well.
Wait.
That was my next question, whether or not they shared in rearing young.
Yeah,
But
definitely
is the 80% of the sharing, is that female bat to female bat? Is that what it means?
Yes.
Because they're not like sharing to male bats, and then the male bats are just like, yeah, I'm not sharing back. It's not like that. It's just the female bats tend to share with each other, and the male bats are like, well, go catch your own. Go eat your own.
So in
Suck your
previous
own buffalo
studies,
or whatever
it was 80% of the sharing situations were female to female. And so in this study, they focused just on females because they wanted to get as many sharing opportunities to observe as possible. So in these tests, they withheld food from certain females to see, when they came back hungry, who would share with them. Then they later withheld food from other females to see who would share with them. So they could see this kind of broad network based on their own manipulations of who did and did not get food. And they found that the empty-bellied bats got less donations from other bats that had been prevented from feeding them previously. So bats that were prevented from getting help before would not give it out, which is pretty much exactly what you were talking about, Kiki. It's, in this experiment, in a manipulated laboratory experiment, they found direct relationship between if you've received it from someone else, you're more likely to give it, and the other way around. If you've given it before, you're more likely to get some as well. So they definitely keep tabs on that, and there was no relationship whatsoever with relatives and who was in a family group or anything like that. It was all about who had been willing to share before, who had been generous in previous situations when someone was in need. Mm-hmm. So these bats, they do have a really good memory for these things, and they just want to know that what goes around is going to come around in the end.
It bloody well better. Oh my goodness. Okay, you guys, it is the end of the first half of This Week in Science. We are going to take a very short break, and we'll return in just a moment with more stories. We've got robot bartenders, we've got some more origins, and vaccines? Lots of fun stuff. Stay tuned. All right, everybody, the holidays are coming, and if you have a favorite TWIS person, or maybe you could put it on your TWISmas list for yourself, there's lots of fun TWISmas goodies. We have merchandise, as always, lots of fun goodies in our Zazzle store. So you can go to TWIS.org, TWIS.org, and look for the Zazzle store link to be able to find all sorts of things, hats, cups, mugs, that kind of stuff is super great. But the really wonderful product that we have this year, it's only happening this year. Maybe we'll do it next year, but we don't really know. Blair has created by hand a Blair's Animal Corner calendar, and it is available to you for, I believe it's $20. $20 for this calendar. It's full of hand-drawn art, and we have picked out all sorts of neat holidays and days that are science-y and geeky in nature for you, and you'll always know when TWIS is going to be on. It's a special TWIS Blair's Animal Corner calendar. You'll know when we're doing a special episode, maybe when there are fun things coming up. So many neat things. The pictures are beautiful, great quality calendars, and we have a very limited supply. I think if you order them latest by December 7th, I believe, December 4th, December 7th, which is only about a week away, week and a half away, that you'll be able to get them in time for Christmas. So if you're looking for a calendar as a gift for TWISmas, get on it and order them, please. That would be fantastic. Just go to TWIS.org. The link is there. You'll find it. We made it super easy for you. And additionally, we are supported by donations. Listeners just like you right there, support us with weekly, monthly donations or one-time donations, and it's the money that really keeps every episode of the show going. So equipment that we need, bandwidth, everything that goes into making the show happen, that helps it happen. What you donate helps make that happen. It also helps us try to do new things, so to make time to be able to edit new versions of the show or to do more TWIS shorts or other things of that sort. You make that possible. And so we have made two ways available for giving donations. We have PayPal buttons on TWIS.org, so you can go to TWIS.org and look for those PayPal buttons. Super easy. We also have a Patreon account, and Patreon, Patreon, it's patreon.com/thisweekinscience. We have links on the website on each show note, in the show notes for each episode. And additionally, you can just go to patreon.com/thisweekinscience, and you'll be able to donate at the level that you are comfortable with. Whichever works, please donate. It really does help us do what we love to do for you. And if you are unable to donate, please just tell your friends about TWIS. Really, just telling people about TWIS helps out so much. Help get people to subscribe to us on YouTube. That would be huge. Or to subscribe to us on iTunes or whatever your RSS feed reader is. Tell people about TWIS and show them, like by hand. Go into their phone or their computer and, hey, It's super easy to subscribe. Here, I'll do it for you. That would really help us out. We thank you for your support. Thank you so much for being a part of the TWIS community. Thank you for all that you do for us. We really could not do this without you.
Put on a pair of goggles and go looking for the things I couldn't see.
And we're back with more This Week in Science.
Woohoo! More science. Hey, do you have a story there, Justin?
Yes, I do. It goes, you breathe it, you burn it, you might even weld with it, if you're a welder, I guess. I'm talking about oxygen. The thing in the atmosphere that makes Earth livable for air breathers. That good stuff. How and why Earth developed an oxygenated atmosphere is one of the most profound puzzles in understanding the history of our planet, says Professor Ariel Enbar of Arizona State University. Brian Kendall kind of agrees. He's a professor of Earth and Environmental Sciences at the University of Waterloo. That is in Canada, I believe. He wants to know whether oxygen concentrations 2.5 billion years ago were stable or not. Unfortunately, there's no way to view evidence of these reactions without a well-preserved section of ancient seafloor. And I wish there was an ancient section of preserved seafloor in which they could study the oxidation reactions of soil that was near the surface way back when. Poof! In Western Australia, an ancient section of seafloor was discovered which holds evidence of oxygen interactions in black shale deposits. New research is revealing that is all thanks to a 2.5 billion year old blue-green algae. Talk about blue origin. Blue-green algae is now thought to be, or has long thought to be, the origin of oxygen on our planet. Oxygen emanating from the algae, as they describe, emanating from the algae in whiffs, little whiffs of oxygen escaping the blue-green algae over, they are saying now, over about 100 million year period. Little whiffs of oxygen were seeping out, seeping out. The whiffs changed the levels of oxygen in Earth's atmosphere until enough accumulated to create a permanently oxygenated atmosphere around 2.4 billion years ago, a transition widely known as the Great Oxidation Event. So, thanks to this little stretch of ancient seafloor, they've been able to find concentrations of elements that they would expect to find if oxygen was just sort of being introduced to clay that had not been exposed to it before. So there it is. Yeah, nice. Life on planet Earth, thanks to blue-green algae.
Thanks, algae.
Yeah, so the algae, because it's photosynthetic, it didn't need oxygen to begin with, so it just started, the algae came about and just started doing what it does.
Doing what it does. And this is, this is why this algae, this is 2.5 billion years ago. It's not a whole lot of predator prey. Nothing's eating it. Nothing's there to mess with it. So it kind of took root. It kind of grew everywhere in all of the early ocean, as it were. And a lot of this early ocean area, they're saying, was pretty shallow ocean areas too. It wasn't like deep, deep, deep ocean. So it was just pretty much everywhere that it could grow, it did grow, and without little emanations that turn the planet oxygenated.
Well, and people don't realize now, that most of the oxygen that we breathe, some say 50, some say 80% of the oxygen that we breathe still comes from the ocean and comes from algae and kelp and corals. And it's not surprising at all that it came from the ocean originally. It is kind of neat to see that it was algae, something that we still depend on to this day for our oxygen.
Yeah, so I guess the question now is if this is enough evidence for to support this as, the big thing that got our atmosphere full of oxygen for us to be able to use, or whether it was part of a bigger cycle. Part of something that involved other organisms or other aspects to that great oxidation event.
Right, and one of the things, but one of the things that they had specifically theorized about is that the blue-green algae. I mean, they thought this was this was the one that was probably it because it's everywhere. There was enough abundance, and they knew it would be producing some amount of oxygen. But yeah, they didn't know if some oxygen got out and then things died out. Boy, they didn't really have a clear picture. And it's sort of a detailed list of minerals that I can't quite pronounce, but they found these deposited in this ancient seafloor in such a way that would illustrate that this was the first time the clay in this seafloor was actually being exposed to oxygen. There's chemical reactions from the clay that release certain other elements, and those elements actually seep out, not just in the oceans, but they seep out on land even, from the clay on land that's not under the water. And as they seep out, then rainfall can take place, and they all accumulate on ocean floors through the runoff. And this layer that they found, which was thick with these elements that they would expect to be reacting out of the otherwise unoxygenated clay, was a pretty clear sign that this event got started and ran and kept going for this 100 million year period. And at that point, now the Earth is oxygenated, so these elements aren't reacting and leaking out like they initially were. And that's the end of that, not the end of the oxidation, of course, of the atmosphere, but the end of the chemical reaction of the initial oxidation event. There could be, of course, lots of other culprits involved in creating the oxygen, but the blue-green algae is the big catalyst, the big driver of it.
Yeah, so thanks to algae for those wonderful exhalations. Poof, 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 poof. And I guess we have to thank not just algae, but bacteria for so much. Bacteria in our guts help let us know when we're not hungry anymore. And since it's Thanksgiving, I thought this was a very appropriate study to discuss. A new study published in Cell Metabolism looked at E. coli and found that they release a bunch of compounds, that when those compounds were put into the guts of mice and rats, that the mice and rats were no longer hungry, and it caused the rodents to release peptide YY, which signals fullness metabolically so that the animals don't eat as much. So the researchers don't know if this is something that transfers to humans or to beyond rodents, but what they're thinking, according to the study co-author, he says, we now think bacteria physiologically participate in appetite regulation immediately after nutrient provision by multiplying and stimulating the release of satiety hormones from the gut. In addition, we believe gut microbiota produce proteins that can be present in the blood longer term and modulate pathways in the brain. And so that's really the exciting and interesting part of this, is that it's not just that there are these compounds being released potentially by bacteria in the gut that affect the gut, but that it's also affecting the brain. And so bacteria in your gut are making you change your mind about whether or not you want another bite of turkey.
So does that mean that if I take a whole slew of antibiotics and I wipe out some of my gut bacteria, will I overeat?
Possibly, and that's an interesting question, and I don't know how that would come into this. And so what they hypothesize is that bacteria self-regulate, and when you eat, or even drink, like you're taking a drink of water right now, when you eat or drink, you are putting more bacteria into your gut. You are adding bacteria to the system. And so there's competition that's going to be going on. And so bacteria that are already in the gut release a bunch of compounds that are basically saying, stop multiplying. We need to stop multiplying, or in other cases, we need to multiply more because there's competition for resources and stuff that has to go on. So the bacteria are responding to the presence of other bacteria and releasing these compounds for their own personal little space war. resource war. But that resource war is then affecting our entire metabolism.
Yeah, and there may be a little self-regulation going on when you're talking about wiping out with a really strong antibiotic. The most powerful antibiotics we have today tend not to affect Clostridium, for one, which can then lead to bouts of diarrhea. So overeating may not be a problem there. Also, your digestive tract can get rather gassy. With the inability to break down certain compounds and that sort of thing. I mean, so in the period of time while you're taking a very strong antibiotic, your digestive tract is going to be in trouble, as it were, regardless. So perhaps though overeating afterwards. This is one of those things. I just went through this using a really strong antibiotic, and I do wish I had Dr. Justin's poop pills, because now I have no idea. Like, how do you rebuild the microbiota? What do you just did? That people are like, oh, just take probiotics. It's like, yeah, but I didn't take those before. I liked what I had before. I got to go back, eat all the same foods. You know, I'm like, can I lick my skin? Is that going to help? Like, I don't know.
Your children. They are probably similar.
I just keep kissing my children. I should get a good portion of it back, right? But yeah, so that's the microbes of your gut directly basically having a communication link to your brain.
To your brain, yeah.
We're just a conveyance for bacteria and DNA. That's it.
I'm telling you, we're just spaceships. We're just spaceships for bacteria. We're big robots. We're meant to move them from one place to another where they couldn't get. It was too far.
Yep, pretty much.
Yeah, and so basically when you are ignoring those signs of fullness, when your body's telling you stop eating and you're like, but there's still pie to eat for Thanksgiving, you're just saying, you guys can battle it out in there. I'm going to keep eating. I'm just adding more bacteria. You guys are just going to have to deal.
Trust your gut, people. Trust your gut.
Yeah. Trust your gut. Just trust your gut. Justin's right. Justin, tell me another story.
This is researchers at Brigham Young University have devised a system to speed up the process of making life-saving vaccines for new viruses. Their big idea? Create the biological machinery for vaccine production on a very large scale, freeze-dry it, stockpile it around the country. Then when a new virus hits, labs can simply add water to a kit to rapidly produce vaccines. Sounds kind of science fiction-y, but they've already got proof of concept of this. They've had some trials to some degree, and looks like it's doable.
That sounds awesome. It's like Kool-Aid for vaccines.
Right? Yeah, pretty much. You can just have it in the pantry or in the lab.
Yeah, or freeze-dried space vaccines.
Oh yeah, you could take these anywhere, right? Yeah, it literally says this is senior author Brad Bundy, associate professor of chemical engineering, Brigham Young. Says you could just pull it off the shelf and make it. We could make the vaccine and be ready for distribution in a day. The research published in Biotechnology Journal demonstrates the ability to store the drug and vaccine-making machinery for more than a year. Traditional systems to produce vaccines for pandemic influenza strains require heavy engineering, specialized laboratory equipment, so specialized that there's only a few labs across the country that even have this equipment. Traditional systems are also time-consuming, sometimes taking months to execute. This new idea is on the angle of emerging method of cell-free protein synthesis, a process that combines DNA to make proteins needed for drugs instead of growing proteins from the cell up, right? It will not only provide quicker response to pandemics, but will also make protein-based drugs more available to third-world countries, where production and refrigeration of storing these vaccines can be problematic. That says William Pitt, study co-author, fellow BYU professor of chemical engineering. While the team is now testing their version of the cell-free recombinant DNA process for vaccine production, they've already successfully demonstrated it for at least one anti-cancer protein. This is, of course, so this is pretty wild. You know, this is one of those getting a little bit closer to that disease-free society, where we may not cure the common cold, but if we can knock it out with a vaccine in a day, comes a lot closer than we've been before.
Yeah, and if you can have that fast response time, then things don't spread as easily.
Mm-hmm.
And if things don't spread as easily, then eventually we will be knocking disease out because we'll be limiting its ability to recombine because it won't be spreading. So,
and of course, the cheaper too it is, then the more accessible it is. And if it's something that all you have to do is add water, that sounds like a lot easier of a route to go, a lot cheaper of a route.
It is. It is a cheaper route, and the thing is too is the idea is you're basically doing what the big labs are doing with a different method of doing it.
Yeah.
But the ability to preserve the laboratory conditions in which you add. Basically, you're just adding the cold virus, say it was, or whatever it would be. You add this to it, and then you can start. You've already built the machinery to create a vaccine. Now you add the thing you're vaccinated against right at the end of it, and so you've moved the process much further along and been able to sort of literally freeze dry it in this case, right? You've been able to pause it right there and wait till you need it instead of having to start everything once you found something you want to vaccinate against.
I just wonder if everything, all of these proteins would freeze dry the same way, if it's just an easy method, or if some would be damaged in the process.
So again, it's what they're freeze drying is the vaccination process, the machinery.
Yeah, the machinery.
The machinery itself to create a vaccine. You don't have to add the thing you're vaccinating against until you've added the water. That's the point. It's that whole buildup of getting ready for something to become a vaccine is already in the box, ready to hit the button, and let's go.
Let's make it.
Let's go. Let's rock and roll right now. You don't even have to know what you're vaccinating against, is what's good about this too. It could be anything, and you're just ready to go.
I love it. I've got another story here about flatworms and researchers who just decided to see if they could give them different heads. Can we make a flatworm grow a different head? It sounds like a Dr. Evil thing. Can I make a flatworm grow a different head? Maybe? I don't know, but they did. So these researchers from Tufts University took flatworm that you might know well, Gerardia, the Gerardia dorotocephala. Sorry, Gerardia dorotocephala. It's a planarian flatworm, and it's pretty good at regenerating. This worm goes through all sorts of regeneration through its life cycle and over again in its life. So researchers know that this would be an easy worm to work with. Well, then they modulated the connectivity of cells in the head area via electrical synapses. And so they modulated and blocked what are called gap junctions, which are the connections between cells where electrical current actually runs from cell to cell when cells are directly butted up next to each other and against each other. And so by blocking these gap junctions, they were able to induce the development of different species head shapes. And it's just amazing to me. So I've got an image here that demonstrates it fairly well. You have a normal planaria flatworm, and then you have the induction of a head shape that's very different. So in this image on the far left of the screen is the normal Gerardia flatworm. It's long, it's flat, and it has these cute little kind of ear thingies or what look like little horns coming out from the side of its head. Give it a little weird electrical stimulation, and they could make it look like other species with differently shaped horns. And so the question here is, okay, why are they doing this, and what are they trying to do it for? Well, they're trying to determine is all of the way that we look based on our genetics? And what their experiment shows is that it's not. That there is actually a certain amount of epigenetic control and also possibly environmental control that influences the development of the body plan. So they found that the differentiation into these different species-specific shapes, actually, it was easier to get the worms to look like more closely related species than it was to get them to look like differently related species or further related species. So there's something to there is definitely something to the relatedness and how the genes are already in place to act and what they do versus what the environment or what this epigenetic control could induce.
Yeah, the question is, if I really want a blonde baby, and I have, there's
Right.
genes for blondness, but they're going to get my dark hair, can I stimulate them electronically just right to get them to grow blonde hair?
And that is the question. So it's not a blonde hair question. That's not what they're looking at.
Right.
But what they're looking at, are there certain deformities, birth defects that occur in the womb or during development for certain reasons that maybe they do have a genetic, they come from a genetic source, but they didn't occur specifically because of the genetics. Is there something that can be done to change the outcome? Can we stop certain birth defects from being defects from even occurring?
Yeah, see, I was thinking all about designer children, but the birth defect thing makes way more sense. That's definitely a more appropriate way to look. When you were saying, why are we looking at this? That's definitely the real reason there. That's great.
Yeah, but then it's like, okay, birth defects, yes, that is what we want to do and to help and to change. But what it does come down to is how if we can. I mean, these are worms. These are flatworms that we're dealing with. Very simple creatures. How much of what they're learning from these flatworms will be applicable to mammals, to humans, and how much will we be able to use this? Will we be able to use this for designer children?
I think it has more of a good evolutionary side to it than, because look, if you did this a little electrical tweaking to a fetus, a chimpanzee isn't going to come out, or a Neanderthal isn't going to come out, or Homo erectus isn't. When they're saying though that it was easy to get them to sort of look like a pretty well related species, my first sort of thought was, well, wow, what if the speciation took place in these flatworms based off of a small environmental change, not so much even a natural selection, but a purely epigenetic change could have been then therefore responsible for speciation of something as simple as a flatworm. And a human, I think, I don't know, there may be targeted areas where this could apply, absolutely. But I think it has a very interesting evolutionary question into how much is genetic and natural selection versus how often and at what level is it possible for epigenetics to actually be responsible for speciation of something.
Yeah, so a lot more research left on this, and the authors are definitely going to continue looking at this. The cell-to-cell communication and that was involved, and how that can give rise to these different shapes and things that they're seeing occur. And dig into the bottom of it a bit more.
Not to reiterate too much, but I'm also in the chat room says, are these heads considered defects or just anomalies in these worms? And I think that's what this is what I was hearing out of this, is that these differentiated heads in these worms look like the heads of other species of flatworm.
Yes.
They were sort of, it was almost as though they were selecting another set of genes that was already existing within the flatworm.
Right. So as far as we know, it's not something that would happen
Oh, no,
normally.
I'm sorry, same genes, but a different expression of the same genes.
Exactly. A different expression of the same exact genes.
Yeah.
Yeah. Somehow the same genes are responsible for these slightly different, these different variations.
So if we took this experiment on a macro scale, just as a for example, and you had a pack of mules that you were doing this experiment on, and at the end of it, some of them would look like zebras. You know, it wasn't like they were defective mules. They looked like a zebra all of a sudden.
Sure.
Sure. Like that, isn't that what?
I mean, taken to an extreme.
Yeah.
I'm not saying you could do this to a mule. I'm saying this in the flatworm,
Right.
this was possible. You made it look like a relative.
Yeah.
Yeah.
It didn't come out looking like a llama. It came out looking like a zebra. Or maybe even, you might have even got one that looked like a horse.
Right. Yeah. So there are these, and they're saying that this is kind of like a new kind of epigenetics. These physiological circuits, these circuits occurring in these, electrical connections, these circuits that are influenced by hormones, the environment, all sorts of stuff. This could be a new kind of epigenetics, different information that we haven't taken into account before.
Nice.
Yeah. So interesting.
Mm-hmm.
Blair,
Yes.
did you have a fun story for us?
Yes. In the circus of TWIS, if you can imagine, in the center ring, I have the amazing, the astounding, tap dancing Finches.
Meep 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 meep.
Perfect. So, an African songbird called the blue-capped cordon bleu. Yes, that's what it's called. They're a monogamous species, and they've been observed a lot because they have this very interesting mixture of song and jumping and head bobbing that they do for each other. First of all, very weird because both males and females do it pretty much in equal time, and that all of it increases as they get closer, or especially if they're on the same perch. There's a lot of jumping and singing and head bobbing. Well, it turns out if you slow this thing down with a high-speed camera, you look at the film 10 times slower, you'll see that the birds are actually dancing. Here, I'm going to screen share, and you can actually see that these guys are, here they are going high speed. So you saw them before, they were just jumping. But now if you look, they're patting their feet in a rhythmic pattern, but so fast that to the naked eye we never knew that they were dancing.
They're pattering their feet.
They're pattering their feet.
Along with the singing that they're doing.
Right.
So
And
they're all
yeah.
trying to be Fred Astaire.
Yes, they are. And they're actually doing it somewhat in rhythm, or at least in frequency related to their singing. So that it will change depending on how they're singing. But these guys, their displays are a lot more complex than we previously thought. They are tapping their feet so fast, we never knew. We thought they were just jumping.
Wow. That's awesome. Not just jumping. Super fast feet. Magic feet.
The
finches.
cordon bleu.
And so now I guess they're going to have to go look at other finch species and see if other finch species do, or even any other birds who have these kinds of dancing behaviors, if they have other things that they're doing at a speed that we don't notice.
Yeah. And then you wonder, why are they doing that if it's so fast you can't even tell? Is it creating a drumming effect that the females are picking up on? Are they picking up on the vibrations? Or can the birds actually see it at a higher frames per second than we can, and they're detecting this dancing visually, even though we can't?
I bet you that's true. I bet you that part of it, that aspect of it, is likely true. When you listen to a bird chirp in slow motion, for instance, you hear a lot more information that passes us by in our slow ape brain way of hearing things, right? When you hear all of that differentiation and that detail slowed down in a bird song, it kind of makes you think, yeah, what's the point of making all that differentiation if nobody can hear it? And of course, then you assume, yeah, then perhaps they are sped up into their hearing in such a way that all of those differentiations come through clearly.
Mm-hmm.
So why not the foot tapping as well? That would make perfect sense.
Mm-hmm.
Or additionally, if the birds are on the same branch as the females or the males, they're on the same branch, maybe they are actually sending physical vibrational information that can be felt through the branch.
Right. So that would be the really interesting thing to see. If it's an audio cue, if it's a sensational cue where they're feeling the vibrations in the branch, and or if they're actually seeing what the other bird is doing.
I like the. Yeah, it could sort of be a mating thing. Look, I weigh this much. I'm well fed.
Well, then just the jumping would be good enough. They wouldn't need the fancy pants dancing, right?
Yeah.
Look at me! Look at me! Look at me! Tardigrades. We all love tardigrades, right? The little water bears.
What?
What? Water bears. Cute little chubby microscopic aquatic creatures that are indestructible and amazing. They've been to space and survived. You find them in just about everything, everywhere. I don't know. These tardigrades are fantastic. The terrific tardigrades. Anyway, researchers decided to look at their genomes and find out exactly what makes these tardigrades so fancy and special. And their paper is published in the Proceedings of the National Academy of Sciences. Turns out that 17.5% of the tardigrade genome comes from not tardigrades. Comes from other organisms, plants, bacteria, viruses, funguses, fungi. And the question is, where did it all come from, and how did it get into the tardigrade genome? The researchers who did the study say, okay, well, they entered probably most likely through horizontal gene transfer. So this is a process that takes place, we know, between plants, fungi, bacteria, viruses. This happens. The genes get mixed back and forth all the time, but it's very rare to find this much foreign DNA in an organism. And the researchers think that what happens is the tardigrade desiccates during the dry season. So when it dries out, it goes dormant, and then its DNA breaks up during that drying period. And then when it is exposed to water again, the cells start to expand, and there are gaps in the cell membranes that basically form leaky membranes, so that water and all sorts of stuff, including the DNA possibly of nearby organisms that have also desiccated and broken up, start mixing and entering the cells and the genome. And the researchers say that if it possibly happened to a cell that is responsible for passing on genetic information, then that would mean that DNA would get passed on. So this is what they think happened. The other interesting aspect of this is that tardigrades also have a very, very large amount of genetic material responsible for dealing with stress. So that would explain why they're so good at dealing with stress. Yes, so they have many genes related to surviving, drying out, having their DNA repaired, probably set it up so that it's very easy if other genes are transferred horizontally, because they have such a good DNA repair system for their broken DNA, that would potentially lead to the incorporation of other DNA much more easily. So there's, positive feedback loop, very likely, led to all this. Interesting tardigrades get even more interesting.
Yeah.
And then robot bartenders. Have you ever had a robot?
Yes.
Have you ever had a robot bartender?
I have once. I had one drink made by a robot.
If you have the opportunity to have a drink made by a robot, take it. It's a great opportunity. There's a wonderful competition in the Bay Area, and actually I think the competition goes other places, but Barbot is the name of the competition, where robots make you drinks, and it's really fun. It's an enjoyable event, and the bots compete to be the best robot bartender. But that's not what this story is about. This story is about researchers at the Cluster of Excellence Cognitive Interaction Technology of Bielefeld University in Germany. They are trying to figure out how to create the best robot bartender, and we've reported on this previously. Their previous research has found that there are certain cues that human bartenders pick up on when they're going to serve a drink to a bar patron, and usually that means that the bar patron has to be at the bar and then make eye contact with the bartender. The third thing, possibly even ask for a drink.
Oh.
Yes. So previous research has shown that these are the things necessary to get a drink from a bartender. So this experiment that they did put humans looking through the eyes of robot bartenders and seeing the cues that the robots would be seeing, and then the humans were deciding whether or not to continue with serving a bar patron a drink. And the short summary of this is that they determined that humans are able to pick up on things and continue with the process of serving a drink when robot bartenders are not. So say a bar patron comes into the field of view of the cameras on a robot, is able to get eye contact with the cameras of the robot could potentially start asking, would you like a drink? And then maybe if during that process somebody got in the way or that patron moved out of the field of view, in that situation a robot would probably just stop and forget that they had just talked to that bar patron and move on to another patron and never serve the drink. Whereas a human could hear an auditory signal of that patron being pushed out of the way and asking for a club soda or a beer or whatever they want to order and continue the process of serving the drink. And so the researchers are learning that there are these things that are important that robots aren't necessarily good at. And so teaching bartending to robots, it's not that easy. World robot domination, not necessarily going to happen in the bar.
Yeah. Is the robot bartender a good listener?
That is the question. Yes.
Does he want to hear about my bad day?
That's what we all hope for, right? You know, you got to have your bartender therapist robot.
Uh-huh. Yeah, exactly. And then you have to have the robot go, I think you've had enough.
I think you should be cut off.
Let me call you a cab.
Let me turn into a cab. I will grab you.
Yeah. Humans not disturbed by technical information like that. Yes. Are we done with the show? Did we do it?
I think we did it.
We got it.
Good job, you guys. Thank you so much for another good show.
Thank you. I'm thankful for all of you.
I'm thankful for y'all too.
Awesome. This is TWISgiving, everyone. It's time for thanks, for giving, for Thanksgiving. TWISgiving. Thank you so much. And I'd like to take this moment to say thank you to our Patreon sponsors. Thank you to Kevin Parachan, John Ratnaswamy, Steve DeBell, John S. Schneiderman, Rudy Garcia, Gerald Sorrells, Greg Guthman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Patrick Cohn, Shane and Tara Ginsburg, Richard Onemus, Kevin Donald Wesley Ballard, Byron Lee, E.O., Bob Calder, Jared Lysette, Ulysses Atkins, Brian Condren, Jake Jones, Trainer84, Kati, Edvardus Rimkus, Brian Hedrick, Cassie Lester, Sarah Chavez, Steven Strowiak, Layla, Marshall Clark, Charlene Davidson Henry, Don Kamarechka, Larry Garcia, Randy Mazuka, Ed Dyer, Tony Steele, Dave Friedel, Daryl Lambert, Robert Aston, Michael Perez, Shuwata, Stephen B., Dave Wilkinson, Steve Mashinsky, Rodney Lewis, Braxton Howard, Phil Nadeau, Rick Ramus, Salgood Sam, Matt Sutter, Emma Grenier, Philip Shane, James Dobson, Steve Goodwin, Kurt Larson, Stefan Insum, Michael George, Craig Landon, Russell Jensen, Mountain Sloth, Jim Drapeau, Tara Payne, Alex Wilson, John H. Maloney, Jason Olds, James, Noah Wiles, Paul West, Alec Doty, Illuma Lama, Joe Wheeler, Dougal Campbell, TMRO, Craig Porter, Adam Mishkan, Aaron Luthen, Marjorie, Paul Stanton, Scott Lajewski, David Simmerly, Tyler Harrison, Ben Rothig, Colombo Ahmed, and Gary Swinsberg. Thank you so much for all your support on Patreon. And thank you, everyone, for supporting TWIS in whatever way you are able. Just by listening or watching is fantastic. If you're interested in supporting us, you can find more information at patreon.com/thisweekinscience. And remember that you can help us out just by telling your friends about TWIS. And on next week's show, we will be back once again, broadcasting live online, 8 p.m. Pacific time on twis.org/live. You can watch there and join our chat room. But if that doesn't work out for you, don't worry about it. You can find our past episodes at twis.org/YouTube or just twis.org.
Yes. Thank you for enjoying the show. TWIS is also, of course, available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have a mobile-type device, you can look for TWIS, the number 4 Droid app in the Android marketplace, or simply This Week in Science in anything Apple Marketplace, including Apple TV.
For more information on anything you've heard here today, show notes will be available on our website. That's www.twis.org, where you can also make comments and start conversations with the host, as well as other listeners.
Or you can hit us up directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWISscience, at Dr. Kiki, at Jackson Fly, and at Blair's Menagerie. We love your feedback. If there is a topic you would like us to cover or address, a suggestion for an interview, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you have learned anything from today's show, remember,
it's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma. Got the because it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we've said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
It is time for the post show. We're gonna have a post show. Oh no, don't you know? Oh, gonna have a post show. Yo, yo. And this is when we let the words flow. We're gonna talk about science, don't you know? We got lots of things we like to say. Science is the way that we like to say hey. Hey!
I'm in awe.
Science is the way that we like to explain. Hey, yay, hey, yay. What?
My name is Blair B, and I'm here to say I like to rap in a science way. That's all.
There we go. There we go.
Oh my God.
Yes, Dave
Like
Friedel
The
singing.
nerdiest way for me to try to rap right now.
I knew Dave Friedel was joining, so singing. Sorry. Rapping and singing. That's right. It is TWISgiving, after all. What do you do to celebrate TWISgiving? I rap.
I bake an apple pie at midnight.
Oh.
Awesome.
Interesting.
Oh, come on. Chat room. You don't like geeky white girl rapping? Come on.
Please stop.
I know. Please stop. Don't do it anymore. Come on.
We did it ironically, right?
Mm-hmm. That's right. Ironically. I think I'm close enough to being a millennial that I can say ironically.
Yeah. Mm-hmm. You definitely can.
Yes. I'm warm, you guys. I have an electric lap blanket. It's very nice and toasty. It's keeping me warm. Although my throat almost gave out on me this evening. Good gracious.
Oh no.
So we got to visit your home, Blair.
Yes, but not me.
Not you. And you just it was like a snuffleupagus moment where I wanted
You're like,
you.
does she really exist?
So Ted shows up. So I go there. We go to the zoo, and Ted is a member already. Ted apparently takes his kids there all the time. Sometimes just to the playground.
Ted Dunning.
Ted Dunning.
ex-host of
one of
This Week
the
in Science.
founding members of This Week in Science.
Yes.
So Blair comes out, and Blair's busy. She's like, I'll try to see you guys later. I know, but try to show, see the exhibits, go right, do all the thing. And then she walks away right as Ted is walking up. And I'm like, no, they didn't get to me. It was really unfortunate.
Next time.
Yeah. Although you may have met at some point, because apparently he's at the zoo quite often.
Possible.
So you may have seen him and his unruly kids wandering around. But yeah, it was really, really nice day at the zoo. Everybody was sort of puzzled by your polar bear.
Yes. Probably for several reasons. She's the second oldest polar bear ever in captivity.
Ever in history, right?
Yeah.
And the oldest one is dead, right?
Oh.
No, because then it wouldn't be the
The
oldest.
second
because
oldest.
there's one that was like 42 that died like a while ago.
Mhm.
But
Yeah, so she's 35.
yeah, but also like much smaller than I thought a polar bear should
So
be.
that's a female. She's a pretty big female. Female polar bears are about 500 pounds. Males can get to be 1,000 to
I
1,500
think that's
pounds.
what I was picturing in terms of polar bear. I
Yeah,
think the last
so
polar
males
bear I
are
saw
2
was
to
a
3
male.
times the size of females.
Okay, that makes sense then. That's
Yeah.
because I was like, that's
She's
really
also
small for a
very
polar-
dirty because she likes to dig.
That's fine. I mean and I've seen green polar bears too.
Yeah.
Like I understand
Algae.
that.
Mhm.
Yeah.
Algae in the fur, right?
Talking about algae again.
Yeah.
Oh, comes
The grizzly bears were really adorable and cute.
Oh, they're hams. They're little hams.
Yeah, they were fun. Those are some fair. The rainforest exhibit was really cool. Really dug that. Everybody liked that. Almost got into trouble right off the bat though.
Oh no. Did you put one of your children on a railing?
No,
Oh.
one of my children ran under and was heading into the reindeer exhibit.
What?
Yeah, that's not good.
Yeah,
No.
it wasn't. It's not that. It's not as secure. It's like a temporary exhibit or something. It's just
Yeah.
sort of like a fence. That's
Yeah,
there.
it's a fence. Okay, so hold on. Let me go on record as saying zoo exhibits are designed to keep animals in, not people out.
Right. But she wanted to go and ride.
Ride a
yeah.
reindeer.
Well, that's where you, as the parent, come in.
No, I stopped there, but we were looking, and then she was like, mine, and then boom, right under the first rail.
Sorry.
Right, and I had to go and grab her and pick her back up over the thing.
Oh,
So that's it all ended well.
Kids do that though, where you turn one way, you're not paying attention for a second, and they just run.
Yeah.
There's no
there was
bolting behavior.
there was a little bit of chasing of the peacocks.
Yes.
Ooh, naughty.
Well, they were just they were
They're
following us everywhere. I mean, everywhere we went.
Peacocks are just
And-
out at the zoo, though.
Yeah,
they're
they
like
were.
they're just
And-
around.
And it was a really nice day to be at the zoo because it had been raining that morning, and so I think people who might have considered going to the zoo crossed it off.
Yeah.
So we had the run of the place. It was really nice. It was,
Yeah, I was wondering if you were still going to come because of the rain.
oh, we were fearless. Had an emergency poncho ready to go. Never needed it.
No good.
No, it was a nice sunny day. It was perfect. Yeah, I think we got to see just about everything. Except the lions. We missed the lions. We saw the
Yeah,
rhino.
so they've had access because there's that little cubby.
Yeah,
so-
we got to see. There was like 4 lion cubs at the Sacramento Zoo last year. They were just stupid adorable.
Yeah, these lion cubs are, oh my god. If you guys want to check out the San Francisco Zoo's Facebook, there's pictures of the cubs all over it. It's so cute.
Aww.
So a couple questions in the chat room. Dave wants to know where his calendar is, and I'm sure it's on its way.
It's coming. It's
Um,
coming.
And Rights for Robots, if you want a signed piece of artwork, it's very easy. All you have to do is pledge the right amount of monies on Patreon, and you will get a signed original piece from me. The original one, not a scanned version. I still have some unclaimed artwork that's in the calendar, so yeah, look there, Justin's holding up his. So you can have that.
Not
Yeah,
this
see-
one. This one's mine.
Not that one. But I still have a peacock spider and which ones do I still have? The T-Rex and There's one more I don't recall. I have 3. The desert tortoise. Oh my gosh, those are like my 3 favorites. And all of them are still if you guys don't claim them soon, I might just have to frame them and put them up in my house.
She'll keep them.
I will.
If nobody claims it, I'm taking that T-Rex off your hands.
A T-Rex is so great.
I'll donate to get it, whatever. Like, I don't care.
I think that one might be my favorite. But right now, this weekend, I'm actually going to be experimenting with some different mediums so that I can start doing artwork for 2016 for Patreon premiums. They're going to be totally different. This series of artwork is looking this way with these circles and the colors and the black and white animals. Next year's artwork is going to look totally different.
Totally.
How different? Not sure. Have not figured it out yet.
It'll happen. It'll come.
Yeah.
It'll happen.
Yeah. Someone asked what my favorite animal is. I'm sure other people are aware that my favorite animal is the hippopotamus.
Mm-hmm. I am very excited, though. I mean, it's fine to be harassed a little bit about the mailing of the calendars because it just means people are excited.
Yes.
So that's cool. I'm glad you guys are excited.
Yay.
It is
I'm
exciting.
really excited.
They are exciting. They're very exciting.
You guys got to tweet at me when you have your calendar and you hang it up.
Yeah.
I want to see it on the wall.
I still need to get mine framed. I keep meaning to go down. There's a framing shop downtown, and I keep meaning to go down there, but I keep forgetting.
Get your artwork framed.
I keep forgetting that, like, I'm down. I go downtown, and I'm like, oh, there's the place, the framing. I just don't have any artwork on me.
So I'm trying to think. I want to say that the papers that I sent out, so I think the original paper was 8.5 by 11, which means that one's going to be 8.5 by 5.5, I think. But you should measure it to make sure. So you might want to put like a mat. I think it'd look real good with like a black mat.
Mm-hmm.
Yeah, that's my opinion. Oh, I'll do a squirrel and a llama next year. That's easily done.
Here we go.
Squirrel and llama. Done. On the list. I might do a whip scorpion too, since somebody kept sending me pictures of that. Who was that? Someone tagged me on Facebook. Me and Kiki, you were in it too.
Oh.
The video
Which one?
of the tailless whip scorpion on Facebook.
Oh, that was Patrick, who
Yeah.
I thought, I was wondering what that was. That wasn't a spider?
It's an arachnid.
Scorpions are arachnids, but it
Yes.
looked like it looked like a spider. It was not.
Yeah, so it's a tailless whip scorpion, and those things actually they're not scorpions either. They're in a separate group within arachnids from scorpions and from spiders. They're a separate type of arachnid, whip scorpions. And then these guys are the tailless whip scorpions that have the super long arms with the pincers like this. So.
Cool. We should show pictures. Let's find. Where is that?
Okay, I can.
Tail.
Yeah.
This.
I'll go into my Facebook and find the video that you did.
Yeah, you can find the video. I will. It's a pretty nightmare-inducing looking thing. Oh, that's what they're big too.
Yeah, they're real big, but they are completely harmless, by the way.
Okay, you guys, here's something that's nightmare-inducing, but completely harmless, just so you know. For future reference, you don't need to be afraid of this very scary-looking thing.
But just to be clear, not armless. Many arms.
Many arms. Okay, so this, what is up with all of the grabby things?
Yeah.
What?
Yeah.
This.
Mm-hmm. Here we go. I'll screen share the video. Here we go.
Okay, let me finish screen sharing so that here
Okay.
I'll stop. It's your turn to screen share. There's the video.
Here we go. This guy's not being smart. He's messing with it in a fashion that is not appropriate.
He's harassing it. But
Yeah.
can you get bitten by these things or?
No, but the little pinchies hurt.
Yeah.
They're not dangerous. They're not venomous. They're not poisonous. I'm sure it would hurt if you got snapped by those things. Like in the video, you hear the guy go, "Ouch!" But
I didn't have the volume on. I didn't hear that.
yeah,
That's funny. Ouch. Oh, whoa.
yeah.
Oh, look at this, you guys. This is terrible. This is a big bunch of tailless whip scorpion babies.
Ew.
You see this?
Wow.
I don't like that. I'm not a fan. I'm gonna go ahead and click the no column on that one.
No, don't like that one.
Pass. Hey, but I'll draw one. I'll draw a tailless whip scorpion this year.
Wow.
Ouch. I got the
That's
GBs right now.
that's wild.
They're so big, too. Did you see the size comparison to that guy's hand?
Yeah.
It was like bigger than his hand.
Yeah. These things are large. Oh, I'm not going to share that picture, but I found a picture of somebody with one on his face.
I want to see it. Share it.
Okay. It takes up the whole guy's face.
Oh,
Oh my
boy.
God, is this a meme? There's a whole bunch of them.
Oh, my goodness. I want to see a meme. What does one of them say?
No, I don't know.
Does it say nope, nope, nope?
No, it should just be nope, 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 nope.
Oh, hey. He's like, it looks like he's smiling.
I think he is smiling. He's totally
Yeah.
smiling. He's a biologist. Biologists do things like that. How
Yeah.
about that one?
Yeah.
Or that one? Here, put it up to your face. Oh, they must have all had a camping trip together. Look, oh, there's one on your face. Oh,
Uh-oh.
look, there's one on your forehead. Oh,
Mm.
look at those big sparkle things. They must have had a camping trip together or something.
Wiz Mike, yes, a lot of zoos still have the wax cast figurines. I don't think the zoo I work at ever did, but I went to the Toledo Zoo and I got a hippo of one of those, obviously. Duh.
I'm just looking at the chat room now. There's this whole bunch of nope. Dave Friedel, dump truck full of nope. CR1, game over, man. Game over.
Oh my God.
That's right. And 2 months later, exploding chests. Oh my goodness.
Not the beard. You're right, Identity 4.
Oh,
Not the beard.
Where did
Is everyone having a
Justin
good
go?
Movember?
It is no. Oh, did Justin shave? I think he was really trying to.
did.
I think he was really trying to be French last week.
Oh, yeah.
I think he was showing French solidarity, and he just said it was Movember. Because you look at his face this week. I don't. No, let's look at his face this week. Look at his face. Yep.
Mm-hmm.
Yep.
Totally forgot that I got this thing in the mail the other day.
What?
This thing.
What? It. Oh, what is that? That looks cool.
It's a home genetic test thingy we're doing.
Ah.
Neat. Awesome.
What is that one supposed to tell you? I thought you already did 23andMe, didn't you?
I did, and now I'm curious to do this one, which is apparently the bigger one with a larger population database, blah, blah, blah.
Oh.
It also costs a little bit more money, but kind of curious also to compare results.
Yeah.
To see if their algorithms are the same. And I have enough diversity within my genome that it's not going to say, yep, you're still all from here. Right? Like, percentages could be affected. Like all sorts of things. I'm just really curious to see if they just correlate, if there's more layers of detail. I just got to figure out how to use this kit. There's more reading involved than the last one. Oh, wait, here we go. Quick start guide and consent form. 1. Collect DNA samples from your cheeks with the enclosed swabs. Don't worry, it's painless. Review checklist, read and complete consent form, blah, blah, mail along with your cheek swab samples in the envelope provided. It seems pretty simple. I don't know what it's even got how to do this with pictures. This is what
I was going to say, there's probably pictorial instructions.
I seem to be missing something though. All right, where's this? Is this? Let me grab one of these things. Take this and then. But where's the thing to put it in? Okay. With clean hands, carefully open the plastic blah blah blah. Using one cheek swab, scrape vigorously inside 45 seconds. Inject the swab tip in one of the small vials. I don't have the small vials. That's what I seem to be missing. I don't see any small vials. Oh, wait. Here we go. It's hiding back in here. Small vials. Ah! Okay. Get 2 swabs and 2 vials. Why do I have 2? Oh, repeat it with the other cheek using the second swab and the second vial. Place both vials on the small. I can do this. All right, I'm going to do it right now.
Great. On air.
Yeah, do it.
Yeah.
I like it.
Going back to step 1. Step 1, with clean hands. Yeah, good enough. Carefully open the plastic wrapper of one of the cheek swabs. Carefully open. It shows somebody doing it with their fingers, but it seems like I might need. Oh no, right here. This might be the hardest part of it all. It doesn't seem to be an easy way to.
This is the IQ test at the beginning.
Okay. Produce. This is my swabber thingy.
Nice. Ooh, it looks scratchy.
It does, right? Using one cheek swab, scrape vigorously inside one of your cheeks many times for 45 seconds.
Oh, okay. Here, you want me to time you?
Yeah, go ahead.
Okay, I'm timing you. I'll tell you when to stop. I know, it's a long time. Keep going.
Ow, how vigorously is this? Is this too vigorous? Ow.
It says it's not supposed to hurt, I thought.
Well, I'm being too vigorous then.
Very scientific, Dave says. Clean hands. Well, good enough. Okay, you have 5 more seconds. Stop.
Okay. Okay. It says eject the swab tip into one of the vials. Okay, so here's the swab. How do you inject it? Eject? I don't see an eject button.
You throw it in.
This. I got it. I got it now. There's a little thingy here. Oh, bump. There it is. So here, I'll show it on the next one because I realized I did that all off camera. Okay, here's the little vial. The swab tippity thing is now in there. Okay.
Nice.
Good job.
All right. So here's. Let me go find another one because I didn't show that very well.
You have to do the other cheek now?
I don't know. It didn't say it. Let's see. Well, it says close the cap and the vial. Oh shoot. Leaving the swab tip inside. Vial must be shut tightly to ensure quality of your sample. Yes, that was achieved. Then it says repeat those steps. So here's the swabby thing, and see that the end tippy part, the thing that looks like a serrated plastic knife. That can actually, there's a tip at the end that will actually push that little bit out, and so when I press down on this part, that popped out. All right. So ready for the timing?
I'm ready.
45 seconds. Other cheek commencing.
Okay. Wouldn't it be funny if I let you do that for like 10 minutes?
Just keep swabbing.
Like, no, it's only been 30 seconds.
Just swab, de swab, de swab. Ooh,
You're at
that
20
swab
seconds
against your
right now.
cheek must feel amazing.
I brushed the inside of my mouth anyway. So.
Yeah, I bet you feel all those little white, little swabby hairs grabbing onto the inside of your mouth, soaking up all your spit.
Does it say anything about if they want you to brush your teeth before?
Nope.
Okay, stop.
Okay. So here's the thing. I open this up, which seems to be filled with some sort of solution. There seems to be a little bit of a solution in there.
I'm sure.
I take this, and I put it into the vial, and I press down here, and the swabby thing is now inside the vial. And I have a second sample of my DNA. It says place both the vials inside the small plastic bag, which is this here they also provided. Very nice. Let's go 1 and 2. Go in there. And place the bag along with your completed consent form into the pre-addressed envelope also somewhere.
Like, hey Justin, can we have your genes? Hey, it's totally cool if we clone you, right?
Yeah, actually, I would totally be for it. Like, I have no complaints. All right, so this goes in here. If you don't, I gotta find this consent form and fill that out, whatever that is. Let's see. I don't seem to have one. Or is it? Oh no, here it is. Is it?
That's like the third time you said that. I don't have that. Oh, there it is.
Oh, you got it. Look for it. Let's see. Is this it? Checklist. It's all checklist after checklist. Oh. I need a pen. That's one thing. It's not provided with the kit. In case you order one of these, you have to apparently provide your own pen. Must send your path. Please make sure you do this. Now place 2 vials of sample provided in the mailing bag. Prevent leakage. Ensure yes, tightly sealed. Mark the type of sample on the back side of the consent form. Is this the consent form? Oh, I see. And this is this is it. I detach this. Okay, this is part's not very exciting, but I'm now detaching the consent form, which apparently does not require a signature, which is interesting. Just put that in there. No signature required. I love how consent is now not even requiring a signature.
Really? It's just like, oh, you're just doing it. So that's your consent. It's done.
Be sure to affix proper postage. Also not. It's pre-addressed, but not pre-postage.
There you go. You gotta go to the post office, buddy.
Son of a gun. I didn't realize that part.
You have to put postage on it.
Mailing within the U.S. will require at least 5 stamps. Maybe more if you've got really meaty cheeks, I guess. All right. So, yeah, there we go. I've got to go to the post office. And then...
Dave says he wants to watch you put the stamps on.
Okay, I guess I'll have to hold on.
Snark.
Wait, I might have stamps. I never use stamps. Where would I have stamps?
It was sarcastic, Justin.
He's gonna do it. Thanks for asking there, Dave. Now we all get to watch him put the stamps on.
You did this, Dave. You did it.
Okay.
No, I don't own stamps.
I'm gonna need to go soon because I have to start baking a pie.
I thought that wasn't until midnight tomorrow.
No, I'm hoping to be done with it by midnight tonight.
Oh.
The oven is otherwise occupied all day tomorrow. with like turkeys and stuffings and things.
All right, so my envelope is sealed. My sample is in.
Stuffings.
I just now need to go to the post office. I need to rely on the post office to deliver my DNA to the scientists.
It's nice that the post office doesn't mind sending DNA to people.
Yeah.
Right?
I know. Anything hazardous in here? No, just, my DNA.
Just my DNA. That's it.
Yeah.
That's all.
Yes, right. It's robots. They may come back. Yes, you seem to be 50% alcohol and yeast. We don't quite understand how a human beer hybrid was formed.
A human beer hybrid.
Rights for robots. The first hour of this process is going to be peeling, coring, and slicing apples. So.
Apple pie process.
Oh,
Yes.
Can we watch that?
Yeah.
I don't think it's particularly interesting.
Not to you, but to foodies out there everywhere. Yeah, this is like what they live for.
Fair.
To the foodies everywhere.
I don't really want to get apple all over my laptop, though.
Mm.
And microphone.
Sounds like a Windows commercial.
But
Nice glossy thing. Pictures of far off people,
being
different places,
different things.
doing different ethnic-y stuff.
Yeah.
Like that guy. Look at that ethnic guy. Where is he from? He's so tall. He's taller than that mountain. Look, you may come from a place with colorful textiles.
There you go. I come from a place with colorful textiles.
You may be somebody with varied eyebrows.
I come from a land down under.
Look at all the eyebrow choices humanity is faced with.
Choices, huh?
So many choices humanity had.
Because I choose my eyebrows.
Yes.
Choose you.
You are
I
adding
suppose-
your own story or your own chapter to the human story. Also beware of sharks. Yeah, totally rad. Totally looking forward to this. Excited about this. This came actually like a week ago. I totally forgot I had it. Super cool. All right, Blair, you've got to go core and apple. Kiki, you've got to get some rest and recovery under heated blankets.
Yeah, under my heated blanket.
Remember, though, heated blankets create magnetic fields that cause cancer or something.
Oh, right. Oh, that's okay. I'm just going to go drink bourbon. It'll make everything
Oh,
better.
that actually cures it. So.
Or the magnetic field could make you grow a chimpanzee head? Is that what we talked about?
We did talk about that, yes.
That's how that worked. I think
maybe
that's
that is how that
exactly
works.
How that works. Yeah.
What? Oh dear, oh dear.
You heard it here, folks.
That's not real. It's not true. Oh my
According
god.
to research on flatworms, using a cell phone too close to your head could cause you to have the head of a chimpanzee.
Science, guys.
Science!
It's science.
Warning you ahead of time of the danger of tomorrow.
Oh my goodness.
Yeah.
Oh my goodness. Oh my goodness. All right. Are we
All
going
right.
to do this?
Yeah.
Yeah.
Say goodnight, Blair.
Good night, Blair.
Oh,
Say goodnight, Kiki.
I'll send you guys an email. We have to figure out I have to buy tickets. We have to get our tickets to New York soon.
Yes.
Oh, yeah.
Now.
Yes.
We should be buying
Yes.
them now.
Okay.
So, yeah, so I'll send an email and we'll work that out.
Yeah.
Okay.
I forgot. I almost forgot.
Okay.
And then, Justin, did you get that email I sent you about the voicemail?
Yes. Yeah. I just want. I think I emailed you back. Maybe I failed to. Maybe I
You
thought
failed.
about it.
You
It never
failed.
happened.
Yes.
I wanted to know if I was to do it generically or to use somebody's specific information, like you have called so and so.
Aha, yes, specific information. Yes.
Because I didn't get any of that in the initial email.
No, you didn't. That's a good question. I'll send that to you.
Yes.
Okay. There we go. Now we can say goodnight.
Good night.
Thank you, everybody. Happy Thanksgiving. Happy TWISgiving. I hope that you have a wonderful, wonderful week. And
Listen to your bacteria. Don't eat too much.
listen to your bacteria. Let them guide your brain. That's right. Good night, everybody.
Good night.